Good afternoon, doctor and classmates. Today I will introduce the topic about scientific thinking skills in chemistry laboratories. First, I will introduce some examples and principles of thinking skill in laboratory for general chemistry. First, for a goal-directed design of instruction, we can define goals for the ideas and skills. We want students to learn and design instruction with learning activities and teaching strategies that will provide opportunities for experience with these ideas and skills and help students learn more from the experiences. The second, integrative analysis of instruction can help educators understand the structure of instruction by using a table to show time sequence relationships between thinking activities done in labs and educational goals with activities help students achieve the goals. Part 2.1 Thinking skills using observation and imagination. Observation-based logical networks intercovered different levels of thinking. When our microscopic level observations and connected to science-based mental models of what is happening in submicroscopic observations are connected levels events with interacting atoms, molecules, and ions. And zero symbolic representations as verbal words, visual pictures, mathematical symbols and equations, chemical symbols and reaction equations. Next, about thinking skills using imagination and require to intercover observations including what we hear and read with mental models, and this ability is important for understanding the concepts of chemistry and using them intuitively. Part 2, thinking skills for analyzing data. Physical ideas and skills, students can learn a variety of related ideas and skills. The similarities and the differences between precision and accuracy and between random errors and systematic errors. Why saying 5 or 5.00 is making different claims about the data and your confidence in it, differences between arithmetical processing of data within multiplication and division using significant figures and addition and subtraction using decimal columns. Data analysis and experimental design. A creative and critical design of experimental means requires a careful consideration of many ideas, including some related to data correction and analysis. Correction of errors by using if-then logic. To correct for an error, caused by experimental design or lab technique, we can use if-then analysis of errors by comparing what should have happened with what actually happened and asking what would we observe if we did it correctly. Personally, the logic of science. We can see use hypothetical deductive logic is comparing predictions with observations to make reality checks. That are the essence of science. Hypothetical deductive thinking activities include finding crucial experimentals and using the logic of Neuchâtel. Calibration logic assumes that what happened before will happen again in a similar situation. We can use old knowledge about laws to generate new knowledge about rules. Conflicting factors occur in many situations, and students should learn how to estimate the influence of various factors and cope with the challenges of complex real-world situations, not just the idealized simplifications. Experimental design is an important scientific skill and is a prominent activity in the daily lives of scientists and engineers who design experiments by using ideas from this page and many more, including knowledge of errors, random and systematic, and strategies for optimizing the effects of conflicting factors. Part 4 about the process of science. Criteria for consensus. One way to help students understand the process of science is to ask what evaluation criteria do scientists use when they make decisions about the series and research programs to reach individual conclusions and community consensus. Other possibilities include a study of strategies used by scientists when they design experiments and research projects. Part 5 Inquiry activities in science laboratories. Principles for inquiry. How can teachers design inquiry activities, which occur when students don't know what to do next, so they must think on their own, and they are allowed to think. They have an educational optimal level of difficulty. How much should inquiry be used for lab instruction, and in what ways? Experimental activities can help students learn to use observation-based logic and make mental connections between different levels of thinking, and use their imaginations to build mental representations of chemistry concepts. Example, we observe using human sense to see, to hear, to touch, to taste or smell, plus instruments, watch, ruler, scale, pipette, compass, and thermometer, and microscope, telescope, spectrometer, and chromatography, and help us measure more precisely and observe more widely. We translate raw data from scenes to instruments into observations that we record using symbolic representations. That are verbal words, visual pictures, and mathematical numbers. Next, I will introduce some thinking skill. In chemistry, we can, for our teacher, we can teach students how to think more precisely in chemistry laboratory. First one about critical thinking. This is a very important thinking skills. First, we must need students to know to focus on a question. We do the experiment, so we must we want to give students some methods to find the answers. So they must do the experiment. First, he must focus on a question. Then we should analyze arguments. So we can search some information from throughout the internet. We can analyze this some results from the papers. First, the third one about observe and seek support from evidence. So first of all, for the student, if we do the experiment, we must observe and seek the evidence. So they just why do we do the experiment? Is we want to search some, we want to look for some findings through the experiment. The third about make inferences, induction and deduction. First, identify, understand assumptions. Next, decide on an action. The last one, employ strategies to interact with others and discourses. So I think critical thinking is very important for every student. Also important for our teacher, for everyone. We must have the critical thinking for any how to say, we must have a critical thinking. We have the critical thinking for everything in the world. So next, I will introduce some priority. Good thinkers build on and extend what they to know. How to build the thinking skill? Well, first, the question: can one be a good thinker without knowing anything? First, good thinker need to think with something. So first, we need to think. The second, good thinker has well-structured knowledge. I think also very important. The next about the prior knowledge, the teaching strategies for our teachers, concept mapping and analogies, maximize knowledge, structure, and organization. The students should compare, should contrast, classify, organize, and relate the different parts. Also examine and reflect on their own understanding. So a student must have zero thinking. We do the experiment or we do some methods, do some surveys in class or outdoors, the students should examine and reflect on their own findings or understandings. The next about process information deepening. Nurse literature and good thinker. Direct their thinking, use inquiry-based strategies. First, we ask higher-level questions. For students, we must have a high-level order thinking skills. So we must build develop students' thinking skill. The first one, we must ask students to ask high-level questions. How do you develop high-order thinking skill? Other than teacher questioning. If you want your students to develop high-order thinking skill, teach this and turn over to students what teachers will do for them. Next, learning strategy. Teaching strategy. From teacher questioning to student-generated question. Asking good question is a hallmark of intelligence. The students learn to formulate and find problems and inquire, hypothesize, explain, and solve the problem. So the master is very important. Check and monitor their own understanding. So then students must have their own thinking skills. They must have their own opinions for one thing or for different things from different from others' opinions. So just I think it's very important for students must have these thinking skills. So next, also other teaching strategies for maximizing students to inquiry-based strategy. From teacher designed experiments and project to student design experiment projects. And from teacher assessment to student directed and peer-led assessment. So in the experiment, I also we mainly give the methods, give the ways to let students do their own experiment, or some groups can do the same experiment. Okay. Then next, about cooperative learning. Good thinker work with others in creating new knowledge. The good thinker only work by themselves? No, I think just is no. In current knowledge-based era, students need to learn, work with others. So that's very important, I think. Because many tasks, one student can't do it, can't do it successfully. We must give the students many. The student must get with other students. Because the group, we are paying more attention to group homework. So next, about Cooperative learning focuses on solving complex problems. No fixed answers for creating new understanding in the learning community. Next, about teaching collaborative learning. For teacher teaching strategy, we should connect mapping, generating questions, and reflecting projects are best conducted in collaborative group settings. Computer supports cooperative learning. About cooperative learning, the students should learn to reflect on own knowledge. Work with others is very important. Communicate ideas and develop standpoints. Compare different viewpoints and agree and disagree with reasons. So the students should give their own opinion about something. So about one, maybe the same task, different students have different opinion. So if you disagree on others' opinions, you must give the reason why. So synthesize different ideas. Also extend own and community learning. So, a student, if we want to give the students to develop their higher order thinking skill, they must do this. Use of prior knowledge, deep inquiry-based learning strategy, also encourage about developing higher order thinking. The higher order thinking, we must have these three basic skills. Collaborative learning using of prior knowledge, deep inquiry-based learning strategy. That's also very important. Next, about teaching and learning strategies for promoting higher thinking in laboratory. First, connect mapping. Many experiments, we also give them mapping. We should connect concept mapping. If you don't have the process, if you don't know the process of the experiment, it's very difficult for one. If you do an experiment as soon as one by one, so it's very difficult, I think. Questioning and learning journals and diaries. We must search information from the internet. Also, computer supported collaborative learning. Analogy and inquiry-based experiments, project working, and making experiments. Because through the experiments, we can find the many things. At the same time, need the student to think to find some efforts, and so on. So that's all for my presentation. Thank you for your listening.